Hey guys, this video is going to do just a few applications using solving quadratics. These applications are pretty simple. The only real kind of thing to pay attention to, as long as you know how to solve the basic quadratics, the only thing different you need to do in applications is just make sure that your answers make sense, right? If you have a negative answer where it's not really physically possible to have a negative answer, like, I don't know, in some cases area might be impossible to have a negative answer, then you want to eliminate that answer. And we'll kind of see, we'll see examples of that in the next couple of problems here. Okay, so for the first problem, for the very first problem here, we have the height of a triangular mainsail on a sailboat is 4 feet longer than the base of the sail. The area of the sail is 38.5 square feet. Find the height and base of the sail. Okay, so let's go ahead and draw a triangle. And that's kind of the first thing we always do. Let's draw ourselves a little diagram if possible. Right, so this is the height. This down here, this whole thing, is the base. Okay, now what's the formula for the area of a triangle? Well, that's 1/2 base times height. Okay, so let's see now, what else do they give us? They say that the height of the mainsail is 4 feet longer than the base. Okay, and so H is equal to B plus 4. All right, and then they give us the area. They give us the total area. So out of this equation, they have given us pretty much everything, right? And they put everything in terms of B. So what we're going to do is just fill out the area equation for what we know, right? So 1/2 times base, we're just going to use B for base, right? Times the height, which is actually base plus 4. And all that is going to equal the area they've given us, which is 38.5. Okay, so how do we solve for this guy? Well, we go ahead and expand this side, and then we're going to combine everything on one side of the equation and set it to 0. Then we're going to factor it and find what it takes for those factors to equal 0. Okay, so let's go ahead and expand this guy out. So if we distribute the 1/2 b into each term, we get 1/2 b squared plus 2b, and that equals 38.5. Okay, so let's subtract 38.5 from both sides. 38.5. These guys go away, and we get 1/2 b squared plus 2b minus 38.5, and all that equals 0. So now we need to factor this thing. But there's something about this problem that we don't really like, right? When we talk about factoring stuff, this is going to throw a little bit of a monkey wrench in our plans, right? We could still factor it, but it's just going to be a pain. Right? It's a pain to factor 1/2. You'd have to break it up into, I don't know, 1/4 b and 1/4 b. So what we're going to do is we're going to go ahead and get rid of that fraction by multiplying everything by 2. Both sides, right? Both sides of the equation, each and every term, right? And so this 2 is going to distribute in, and this 2 times 0 is still just 0. So our resulting polynomial is b squared plus 4b minus 77, and that equals 0. Now we're going to factor this guy out, and our factor is going to look like this. Whoops, erase that. So our factor is going to have 2 b's in it. We know that already. It's going to equal 0. We know that already. All right, we have a negative constant term, so that means we want a plus and a minus back here. We have a positive middle term, and that tells us that the larger number will go in the positive spot, right? And so what are the factors of 77? Well, there's 77 in 1 and 7 times 11, right? And so I'm pretty sure it's going to be 7 times 11. So 11 is the larger factor. We'll throw it in here on the positive side, right? So we have b plus 11 times b minus 7 equals 0. Now, the last step to solve is just to solve for each b, right? So we set each factor equal to 0. b plus 11 equals 0. And then we do the same for this factor. b minus 7 equals 0. And then we say, well, if b plus 11 equals 0, then b would have to equal negative 11. And if b minus 7 equals 0, then b would have to equal positive 7. Right? And so our answers to this are that our base either equals negative 11 or our base equals 7. And like I said at the beginning of this problem, some of these guys aren't going to make sense, right? And so this guy, b equals negative 11, does not make sense with this particular problem. So we're going to cross it out. So we're going to say our base equaled 7. Now, what does the height equal? Well, the height, as we see right here, the height was just equal to the base plus 4, right? Right here. Height equals base plus 4. They gave it to us in the problem. So the height is equal to base plus 4, which is equal to 7 plus 4, which is 11. All right, so we have a height of 11 and a base of 7 for that triangle. Okay, so let's move on to the next one. So this one's a little bit interesting. This is one of those ones where they give you the polynomial and they ask you to plug stuff in and play. Uh-oh, my battery's running low. Might have to pause it real quick and plug in my charger. Okay, charger's all plugged in. We're ready to go. So anyway, as I was saying, they give you the polynomial and they ask you to plug in certain values for that, right? And so this polynomial, this is the number of possible handshakes, h, within a group of n people, right? And so n equals people, h equals handshakes, is given by this polynomial. All right, so what they ask us to do, they say, after winning the championship, all Dallas Maverick teammates exchanged hugs. Altogether, there were 66 hugs. That's just lovely. How many players were there? Well, First of all, I'd just like to point out that this is a semi-famous function in combinatorics. So we're not just working with random functions. Okay, so what do we do for this problem? Well, they gave us, in the problem, they gave us that there were 66 hugs. So we already know that h equals 66, right? And that's 66 hugs after a championship game. So there was probably a lot of sweaty dudes there. All right, gross. So h equals 66. Let's go ahead and plug that in, right, and solve for n, right? Because the question asks, how many players were there? We know that n equals the number of players, so that's what we need to solve for. All right, so h equals 66. Let's just plug it in. 66 equals 1/2 times the quantity n squared minus n. Let's go ahead and expand this, right? And we get 1/2 n squared minus 1/2 n. Okay, so now we're going to take this guy and we're going to take this 66 and we're going to subtract it from both sides of the equation, right? And so we're going to get 1/2 n squared minus 1/2 n minus 66. And that's equal to 0. Right, and so we didn't do anything major there, right? All we did was we rewrote this guy as 1/2 n squared minus n minus 66, or minus, sorry, I should write it as we had in the formula, minus h. And it equals 0. Okay, so here we are. And just like one of the other problems we did like this, we have a 1/2 in front of the n. We don't like that. It makes things confusing. So we're going to multiply both sides of this equation by 2 to get rid of that, right? If this was a 1/3, then we'd multiply both sides by 3. If this was a 1/10, then we'd multiply both sides by 10, right? Whatever it takes to get rid of that fraction. We don't like that fraction. Okay, so, whoops, that should not be a 3 there, that should be a 2. So if we go through and we multiply everything by 2, then we get n squared minus n minus, what is that? 132. And that's equal to 2 times 0, which is 0. All right. So let's go ahead and consider what kind of factors. What are we looking at for factors? Well, we're going to have two n's. We know that. There's no coefficient out here, so there's no coefficients down in the factorization. We have a negative final term, so we're going to have a plus and a minus, and we have a negative middle term, so we know that the larger factor will be attached to the negative sign. So what are the factors of 132? Well, there's 1, and then there's 132, and I don't know. There's probably a bunch of other stuff. There's 132 over 2. There's 66 and 2, things like that. But what we indicate here with this middle term, this negative n, right, is that the difference between these two factors is -1. Right? There's only a 1 difference between the two factors. Otherwise, right, if there were a 5 difference, then this would be a 5 in the middle. If there were, with the case of 66 and 2, this would be some sort of form of 64 in the middle, right? But it's not that. It's only a -1. So we're looking for two factors that are separated by only 1, right? So I did a little bit of guess and check outside the video to save us some time, but at home, this really just takes just a small amount of guess and check. The factors we're talking about are 11 and 12. That's it. 11 times 12 is 132, right? So the middle term is negative, which means the larger factor gets attached to the negative. So we'll throw the 12 in there, and then we'll throw our 11 in there. Okay, this guy is equal to 0. Right, and we can see here, right, we're going to break it down into two factors and we'll get two solutions. So if n plus 11 is equal to 0, then n is equal to -11. And if n minus 12 is equal to 0, then n must equal +12. So -11, +12. Let's see which one makes sense with our original problem. Okay, so since n is equal to the number of players, right, the number of people, n is the number of people, and we know that we're at a basketball game, right, so we don't have negative people there. This one, n equals -11, that's not really a valid answer, right? That doesn't make sense with our problem. So n equals 12. Right? So after winning the championship, there were 66 hugs. There were so many hugs. How many players gave those hugs? 12. That's a lot of hugs per player. There's a lot of love in that room. Okay, let's go on to the right triangles. So this last one, we're just going to use a pretty common formula. You're going to have to use it in a lot of different applications in this class and in following classes, and that formula is just the Pythagorean. Right? And it says a squared plus b squared is equal to c squared on some right triangle. Right, if this were right, this were A, this were B, and this were C, then this would be the case. Okay, so let's see if I have a right triangle in here. I do not, but I'm just going to draw one out. Okay, so it says that we have a right triangle, so we're just going to sketch one out here. Right, this is a right angle, and it says that the shortest side measures 8 centimeters, 8 cm. Right, the lengths of the other two sides are consecutive odd integers. Right, what we know from previous classes is that we can represent consecutive odd or consecutive even integers by saying x is the first integer, and then the next odd or even integer happens at x plus 2. Right? Because odds are separated by 2, evens are separated by 2. So we're going to label this side x and this side x plus 2. All right, we're going to label this side as the x plus 2 one because we know the hypotenuse is longer than either of the legs. So the larger consecutive integer goes on the hypotenuse. Okay, so now let's go ahead and set this guy up, right? So a squared plus b squared equals c squared. A squared, we're going to say, is 8 centimeters, right? 8 squared. B squared, that's this leg. That's the x leg. So that's x squared. And that's equal to c squared, right? Which is the hypotenuse, which is x plus 2. X plus 2 quantity squared. All right. So let's go ahead and move to the next line and just simplify this stuff. 64 is 8 squared. X squared just remains x squared. We'll go ahead and FOIL this guy out, and we get x squared plus 4x plus 4. Okay, so right off the bat, we'll see that the x's can cancel. Hey, that's kind of nice. Okay, so what we're going to do from here on out, we're just going to go ahead and solve for x, right? So we're going to subtract 4 from both sides. These guys go away. We get 60 equals 4x. Divide both sides by 4 so that we can isolate the x, and we get 15 is equal to x. So what does that tell us? Well, that tells us that our triangle, we can complete our little triangle, right? So we have 8 centimeters, right? We have 15 as our x, because we determined this leg to be our x. And then this one is x plus 2, so we can just fill in that result. That's 17, okay? There we go. So when you're faced with the Pythagorean, just sort of muscle your way through it. Draw out the triangle, assign values to a, b, and c. Remember, the c value is the hypotenuse. And besides that, just have fun. So that's the end of the applications video. I will probably be putting out some more videos this week, so stay tuned.